What's up, YouTube? So today I want to talk about my newest favorite free modular software synthesizer. So unfortunately, this is not a VST, so we're not going to load it up into Bitwig or any DAW today. This is actually something that kind of is built into Unreal Engine, which is something that I've been studying a little bit lately, and discovered the world of Metasounds, which is like an entire modular synthesizer kind of already baked into the engine, with the ability to kind of use crazy spatialization parameters to enable all sorts of immersive sound design stuff directly in the engine. But yeah, today I want to kind of discuss the world of procedural music. We're going to build a very simple piece of music that can kind of develop and evolve and change depending on different parameters, which we can feed it from the game engine. So I'm going to start by showing you just a quick example of something that I've put together. It's like a space scene with a model that I grabbed off the Unreal Marketplace or Fab. But the idea here is that the music changes depending on the speed of the spaceship. So the faster we're going, the more notes are being added into the sequence, the faster the sequence gets, and that kind of thing. So we're going to try to recreate something like that today. Not this exact sound or this exact patch because it's a bit of a mess. We'll go into a brand new project and we'll start everything 100% from scratch. So yeah, let me show you this quick example and then we'll dive in and recreate something very similar. There's also the engine sound in here. I'm not going to go through that kind of stuff in this video. I'm going to focus more on the music. If you do want more videos about Unreal Engine and sound design within Unreal Engine, let me know in the comments, and then I will do more sound design type stuff. It's really crazy what you can do. Oh, did I mention, by the way, Unreal Engine is free. So for somebody who's planning on getting into sound design, it's definitely something that you should have in your tool belt. Just knowing the fundamentals of how to implement the sounds is going to make you more competitive in the market, if that makes sense. The engine sound we're not going to dive into today. We're going to focus a little bit more on the music. But notice how the faster we go, the more the music changes. Pretty simple track that I've done so far, but you can develop this idea in so many different ways, or you can make it more minimal, or whatever you want to do. Okay, so let's create a new project. Let's just use the first person template. What I'll do is I'll call this Procedural music example. Let's just see if everything launches. Cool, that's working. So what I like to do is create a new folder, which I keep all my audio assets in. And then here, what we can do is we can create a new audio Metasound source. Let's just call this Backtrack MS. So folks who are familiar with modular synthesis will understand a little bit about what's going on over here. One of the main things to set up, though, when we're doing backtrack stuff is we definitely want to work in stereo. So if we click on Metasound over here, we can actually switch this patch over to stereo. And so now we have this kind of like main patch which we can work from. Generally speaking, when I'm doing these kind of backtrack synthesis type things, I would say a really good workflow to use is using sub-patches. So what that means is, say, for example, if you have like a pluck sound, you have that kind of baked into its own little Metasound patch, which you can then load into this patch. So let me basically explain what that is. So if we just minimize here, and now we create another Metasound patch, and we just call this Sign Pluck MS. We open this up. We can leave this as mono. And then here we start to add in some kind of synthesis functions, like a sine oscillator and an envelope. We can just go with something simple like an AD envelope. And then to do some kind of VCA, what we need to do is use the mult. And then we can just mult the output of the sine into the output of the AD envelope. And that basically controls the volume with the envelope. And we can send this to the output. And just to test if it's working, what we're going to do is we're going to send this over here. And what I usually do is, because sometimes it's quite loud, if you're just dealing with kind of raw synthesis values, I will put in a graph input here on another multiply. And then that gives us the ability to kind of change the volume directly in the patch. Cool. Let's save, preview. Okay, so if we want to change these parameters, we can either just dial in the exact values, like decay time, etc., or we can actually create a variable or an input. So the input basically exposes it so that we can patch into it in a bigger patch. So let's go back to the backtrack MS, the original patch that I was talking about, and then let's right-click here, go to graphs. You see now we've got the sine pluck MS. And so here we've got the amplitude and decay time exposed for us over here. So we can send this output into, let's just say, a stereo mixer, and we'll match both outputs and then send these to the outs over here and route this to the play. And let's just test if this is working. Okay, so now what we want to do is we want to create some kind of sequencer. So when we play the patch, it basically triggers this once, okay? There is a trigger repeat, which we can use. And if we set this number of periods, if we leave it at 0, it's going to just repeat indefinitely. So it's basically just going to keep triggering this over and over again. And we can set that period, which is the time, obviously. So you know how these parameters are exposed here, this decay time and the volume over here. So any parameter that's exposed as an input on the master patch, we can actually modulate directly in the game engine. So this period over here, like the speed of those plucks, we can modulate directly in the game engine. So this could be done via like the speed that the player is walking, the closer the player gets to an enemy, or it could be used as a kind of radar. You know, as you look in a certain direction, it gets faster and faster and faster. So already my mind is kind of like thinking of all these different ideas which you could use in a kind of immersive environment with just a very simple pluck sound like this, you know. But in terms of music, we can actually take this so much further, you know. It's not just these kind of modulation parameters which we can set up. We can set up musical sequences, and we can feed it different arrays of notes from directly within the game engine. So remember in the example which I showed you, the notes in that sequence were changing. And it's because as the ship went faster, it was getting a different sequence. And that sequence was being fed directly from the code. So we can do that as well, which is really, really cool stuff. So let's just jump back into this original patch. What I want to do is I want to modulate these settings a little bit here. This decay curve, let's set it to 0.5, just so it's a bit more of a pluck. In fact, we can go lower, 0.2. Okay, so back in the sub patch, what we can do is we can set up a into the frequency of the sine oscillator, we can set up a MIDI to frequency float, right? And then here, what I want to do is I want to go add, right? And then this one we're going to expose as an input. And here, the range at the bottom left, we want to change this to something like 0 to 127. And the default should be 60. And so this is now the root note. So we can change this if we need. Okay, so into this one, what we want to do is we want to use shuffle. It's a shuffle float array, which we want, right? Trigger goes into the next. The reason that we want the shuffle array is because it allows us to shuffle it or not shuffle it. So this allows us to either send it a sequence like 1, 2, 3, 4, and then it repeats it, or it can randomize between that sequence. So we can send it a Boolean, which is true or false, and then that can then generate random sequences based on notes, or it can just play the sequence and loop it over and over again. So by using the shuffle instead of the get or the random get, we can kind of do both with a single module, which is really, really cool. So here, this in array, we want to expose as a graph input, okay? And then back to the master patch over here. So you can see here, it's actually given us an array here. What we need to do is we expose this as a graph input, and then that allows us to actually modulate it and change this array from the engine. So here what we can do is we can just for now add 3 notes, like let's say 0, 7, 8. These are the semitone offsets, by the way. You see, when we change that auto shuffle, we either get randomized or non-random. So the reason that I do the subpatch thing is because now we can just duplicate this and we can send it a different set of arrays or no array, and then it'll just do the root note, right? So if we just duplicate this here, and you see now we have that kind of like chord going on. One is playing the root note and one is changing, almost like a marimba type of sound. Hey, that's actually pretty cool. What we can do is we can put a slight delay on the one trigger, right? So it kind of does a bit of a strum. What we can do is we can also random and then generate a random of any of the types of values within Metasound. So Metasound has 4 different types of values, I believe, not counting the arrays, which can be any of the values, but multiple of them in one. Does that make sense? So it's bools, floats, ints, and times. Random time allows us to send a trigger, and then it randomly generates a time within the range that we feed it. So let's say, for example, between 0 and 0.01. So very slight delays, and it's going to shuffle them slightly. Let's maybe go a little bit higher, 0.1. That's a bit too much, I think. We can also change the pitch here directly. So let's say, for example, 48, which is an octave down. That's pretty cool. Let's add some reverb here. Okay, So that's enough messing around here. Let me show you how to actually implement it in the engine and then mess around with some of the parameters. Remember, we're not just limited to directly synthesizing the sounds like this. We can actually use wave tables, wave players that can load mono, stereo, quad, surround, various different types of sources. It's really a sort of sound design powerhouse, as well as a synthesis powerhouse. Pretty crazy system built directly into the game engine. Crazy, crazy stuff. Anyway, so there's various ways we could implement this. We could spawn it like as an actor in the world, and so it's kind of spatialized. So when we turn, we hear it differently left and right. But for backtracks, we generally don't want that. I think spawning it directly on the character might be a better idea. In this template, the character is basically this BP first person. Okay. The easiest way to do this, I guess, would just be say create an audio component on the scene, and then choose that backtrack MS over here. And what we can do is then drag this into the graph. So this is another really, really cool thing about Unreal Engine is this whole blueprints system. You don't necessarily have to know much about coding to be able to implement simple things within the game engine. It kind of reminds me a little bit of about a little bit of a modular synth or any kind of like node-based programming system. So if you've used Blender's shader system or Touch Designer or any kind of modular synthesizer, it should be really, really easy for you to understand what's going on here. So what we want to do is this audio component that we've added here, we want to play this, right? We want to set it to play. And what we also want to do is we want to make sure that we trigger it. So if we say event begin play and send that to the trigger, what's going to happen is when we start the game engine, it's going to play our backtrack. Let's check if this works. And then what we can also do is directly from this component, we can drag off here and say set float array, right? And then here we can drag this off and say make array. And then here we can just add a bunch of notes, right? So 0, 7, or let's choose a different one. So let's go 0, 3, 5, 7. And one more, let's say 12. And this, let's actually create a new function here. So let's say copy this audio again into the target. And then here, let's say custom event. Add custom event. Let's say trigger audio 1. Like this, right? And then we can actually copy this whole thing, make another custom event, and say trigger audio 2, and then send this in here, and then choose a different array, 0, 7, 8, 10, 12. Okay, and so now what we can do is we can perhaps, in the world, we can spawn 2 collider objects. So when we walk into those, into that space, it's going to trigger that sound for us. So I think the easiest way to do this would be to just create a new blueprint class. Let's call this actor, and music trigger underscore BP. We can actually load this up. And here in the default scene root, what we want to do is we want to add a box collision. Let's just go down and make sure that there's no actual physics collision happening. Yeah, overlap all dynamic. So if you see block all dynamic here, you got to change that to overlap all dynamic, because what we want to do is we want to overlap events. We don't want this collision to block any objects from going through. We just want to trigger some kind of event happening when the 2 objects overlap each other. Does that make sense? Then in the world, what we can do is we can actually just drag that in. Okay. Let's say music trigger BP. Let's drag that in, and we can use the scale over here to kind of scale it up, right? Let's lock this, and we can use the scale to kind of position it in the world. Okay. And so with this one, let's say, open it up and then go down and then say on component begin overlap. So when we begin overlapping that collision object, we want to go to the other actor, cast to whichever character that original function was in, right? And then we can drag off here and just trigger that function. Trigger audio 1, okay? Nice and simple. And then the reason we're doing the cast to that specific thing is so that we can call this function directly. There's other ways of doing it. This is just the quickest method. But also, if you have NPCs and other stuff in your game engine, those aren't going to trigger the object. It has to cast to the first person character. Does that make sense? If it doesn't, it fails and it doesn't trigger the audio. So it's a nice method of being able to do kind of a 2-in-1 like that. So, okay, back to the box collision. We should actually make this the default scene root. And then on component end overlap, we'll do the same thing, but we'll trigger audio 2. So we cast to first person character, other actor which is being overlapped, and then here, trigger audio 2. Just like that. So, when we walk into the box, it sends this array of floats to Metasound. When we leave the box, it sends this array of floats to Metasound. Simple implementation, but I think it kind of gives you a nice idea of how this can work and how you can expand on this idea how you want, you know? So we have the basic one that it starts with. Something is not happening. So what we can do is we can actually just debug something here. Debug. Okay, I figured out what was going on. So we didn't actually name these values here. So these parameters need to specifically be named in the engine so that it can be received here. And I think something like inArray is probably not a very good name to use. So let's just call this notes, and then this one, period, we can call speed, because we can modulate this in the engine as well, remember? So here, let's just choose notes, and let's just check if this is now working. To make it more noticeable, what we can actually do is just make these ones backwards. So let's just say 12, 10, 8, 7, 0. Okay, so what we can also do is let's just do a simple implementation of like the character speed to the speed of that track, right? So usually what I'll do is here in the input, I'll actually set the range over here using a map range, right? So here, let's just go in and listen to it and figure out what the max and min time we want are. Like, let's say 148 to 376. 148 to 376. So let's say map. We can't map the time. Okay, so maybe we have to change this into a float. Float to time, drag this to the input, and then we can just map it here. Map range float. It was 148 to 376. Okay, and then no matter what we do, as long as we send it from 0 to 1, it's going to map this range, hopefully. So we can actually just swap these. That'll be easier, the 1 and the 0. Okay, so back in the first person blueprint, what we need to do is we need to use an event tick here. You may want to use a timer and not do it on every tick. But I mean, it's up to you. It depends on how tanked your performance is already in your game engine, you know. So on the event tick, what we want to do is we want to set the, okay, let's name the parameter, not in, let's call this speed, delete this one, call this speed, and call this speed. And then here we can get the speed of the character using the character movement component. I think it's get velocity. Yeah, get velocity. And then we want to vector length. I believe that will give us the speed. There's also a pretty nifty way of easily mapping this range from the max speed. So if we say in range a 0 to it's from the character movement as well. We drag off get max speed. And you drag that in there. It's going to, no, it's not this one. It's the get max speed, max walk speed. You feed that into the in range B. It's going to map the range from min to max to 0 to 1 for us automatically. So then if we go into character movement and mess around with the speed of the character, it'll always just map this range to 1 automatically, which is a pretty cool, nifty technique. Anyway, so the speed should be determined by the character speed. That's pretty cool. So what we could do is we could also just spawn this in the world here. And if we say override attenuation and turn all these spatialization, occlusion, and all these kinds of things on, air absorption, attenuation, focus, all these on, what's going to happen is it's going to give us the abilities to spatialize the sound. So then let's go into the character blueprint and the event begin play. This one we can just turn off because we don't need to actually trigger this audio component anymore. Turn off all of these. Here also we can just clear this. So you could say, for example, have a radar in a location, and the closer you get to that location, the faster it gets, or it changes pitch or something like that. Like I said, if you want more of that kind of sound design kind of stuff and implementation of sound design stuff, let me know in the comments. Give me ideas of what you might need, and we can look at that in a future episode. But I think that pretty much sums it up for today. I hope you guys enjoyed this little exploration into Unreal Engine. And like I said, don't forget, it's free, unbelievably so. And yeah, it's just something that I believe the sound designers should definitely have as part of their tool belt for getting into the professional industry. Yeah, thanks for watching. If you haven't yet, please consider hitting that like button, subscribing to the channel, and all that stuff. I've got all sorts of presets for synthesizers like Vital, Serum, all that kind of stuff for sale on my store. Links will be in the description, or you could support me on Patreon if you prefer to do so. Thank you for watching. I will see you guys next time. Cheers.